Okay, hi, I'm Baldwin, and I'm going to show you how to do Lonnie Robinson's easy Hartmann test in the shop. So first of all, I have the sit test stand by Bill Thomas. We also use it for easy Hartmann. It has a longitudinal adjustment, a transverse adjustment, a vertical adjustment, and right here is a well-defined plane that everything is based on. If we look down here, we can see, go ahead and point at the mirror. You can see there's a 20-inch f3.6 mirror sitting there. Okay, so the first thing we're going to do, back this way, is we're going to set the stage so that the Ronchi is at the center of curvature of the center zone. So I'm going to turn on my alignment laser. And if you look down at the mirror down there, look right at the mirror. I can put the laser near the center of the mirror. And then if we can point it back up this way, Glennie, I'll look for the return beam. Let me get it off a little bit there. Look for the return beam. It's right here on my finger. So I'm going to have to bring this guy up. And I'm going to have to bring this guy over. And for the moment, on my test stand, works good when the return beam goes right there. Once that has happened, I flip it over to the white light, which is the light coming out there through the Ronchis, goes down, hits the mirror, comes back and goes through the Ronchi again. And I adjust the stand. I'm going to adjust the longitudinal axis so that the center zone is at the radius of curvature. So when you have Ronchis, you get circles that are right at the zone it's at. And when you get it right at the radius of curvature, you got the bars, and that center bar is fat in the center and then goes out. You can tell when you're at the center curvature or the center zone is going, it just kind of bulges right at the center there. So that's where we're at. We're at the center curvature for the center zone. Now that that's been done, I'm going to put my alignment laser back on. I can take off the Ronchi, and I'm going to put my targeting plate on. And this targeting plate was pre-created so that everything works out right. Now, for the easy Hartmann test, I have a lot of targets up here, but for the easy Hartmann test, I want the return beam to be right in the center of that square right there. So, boom, there it is. I'm going to just adjust the transverse just a little bit, so close enough right now. Okay, looking back at the mirror, we can see that's not dead center, but we're going to take care of that. This is the easy Hartmann mask. It's going to go onto the mirror perfectly. And there it is on the mirror. Now I have a white card around my center zone. You can see that the laser is not in the center hole. Laser needs to be in the center hole. So that little white area around the center hole makes it easy for me to do my alignment. And so we point the camera right at that. You can see it's off it. I can move it around until it is on it. Doesn't have to be perfect, but it's got to be on the hole. And then I make sure it's coming back and hitting my center mark, and it is. So, at this point, the alignment laser hit the center hole, came back and hit my targeting mark, and I'm at the radius of curvature of the center zone. Alrighty, now, I'm going to put the camera on. And on the spreadsheet, our measurements for how far back the CCD is from this plate. So you add that guy and this thing here, and that on the spreadsheet, that number is there. And then I could put a pinhole right there, and I will for a minute, but I'm going to take it off. You'll see why. So my pinhole goes just like that. I can't do anything left-handed. All right, now here's what's going on. Here's the pinhole. The light shines out, hits the mirror, and on those 57 holes, reflects back. It converges right about where my fingernail is at the same distance from the mirror as the pinhole, because the pinhole's at the center of curvature of the center zone. Then those dots from the mask spread out and land on the CCD. Now, the too small of a spread, you want them bigger. If they're too big of a spread, you want them smaller. So for most mirrors, like f4.5, f5, we need to move the camera back to spread those guys out a little bit. So we need to move the whole assembly back, but leave the pinhole in the same place. I came to the side, I gotta go back to that side. So what I'm going to do is, you'll experiment till you get it just right, and then every time you test it, you just put it exactly the same position again. So for my experiment, I will take out the pinhole, and I will put on this pinhole extender. I usually put it on tight, but for right now, it's going to be a little bit loose just because I'm just talking about stuff. But imagine that that guy is actually on there secure. It extends the pinhole a little bit forward. So let's pretend that that pinhole is a 1/2 inch forward. That means I'm going to move the stage a 1/2 inch back. That's a 1/4 by 20 bolts, so I'm going to bring it back 10 turns. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that whole stage just went back a 1/2 inch. So if that pinhole extender is a 1/2 inch forward and the whole stage went back a 1/2 inch, then that means that pinhole is still at the center of curvature. Hits the mirror, comes back, crosses right at itself again, and then spreads out to the camera. I take a test shot. Let's say that those dots aren't spread out far enough. So I'll move this guy to 3/4 of an inch, roll this guy back another 1/4 inch. So now the pinhole is 3/4 of an inch forward and the apparatus is 3/4 of an inch back. That returns the pinhole to radius of curvature, but it spread the dots out. So you will do that until the dots are filling up the frame really well, but not too well. You don't want to be right on the edge because we're going to measure stuff. Okay, but I do fast mirrors, f3, f2.9, f2.8, f2.61, whatever. So I can't use that for 2 reasons. Number one, I can't rig it up so that the dots don't spread out. They spread out too fast, they leave the frame. The other thing is, if you're doing a fast mirror, the hole is right there and the top of this box is right there, and those guys hit the top of the box. I can't get them all. So for fast mirror like f2.61, I'm just going to set this pinhole up, and I'm not going to have a setback. There I am back at 0 again. So instead of moving it back a 1/2 inch, because I got a 1/2 inch on the extender, since I'm at the pinhole, I'm not extending it back, then I go back 0. Whichever way you do it, whether you're going back 0 or going back 3/4 of an inch or going back an inch, whichever way you're doing it, that number needs to be entered into cell G6 on the spreadsheet. So if I had this guy back 3/4 of an inch, I would put 0.75 into cell G6 on the Easy Hartmann spreadsheet. Okay, so let's pretend that it's all set up now. Lights go out. I set my camera up for ISO 6400, 2-second exposure. I click a 2-second exposure. I look to see if my dots are too far right, too far left, too far high, too far down. I make adjustments till it's right in the middle. Once it's right in the middle, I reset the camera to ISO 200 and a 10-second exposure, and I make the room absolutely ass black. No light leaks, no door leaks, no LEDs, no nothing. black, and I take a 10-second exposure. Now your exposure might be different because mine's 10 seconds because of the size of my pinhole, which I think is 0.002 inches, but I don't know, and the intensity of my bulb. So depending on the intensity of the bulb and the size of the orifice, your exposures may be different. But you want to have multiple second exposures because of the possibility of slow air movement in the room. You want to make sure that it averages out well. I shoot in RAW. When I get to the computer, I convert it to TIFF. That's for measurement purposes. So as far as setting this up and using it in the shop, that was it. If I forgot something, I'll let you know later. Thank you for Glenda for being my cameraman there. You can kill it now.